Testing, testing. Am I in, hello? I was gonna, okay, great. Hey guys, good to see you. Welcome to Fast Flexible Iteration with Rust and Rhai. I'm not your keynote speaker today, but I am your Keyrock speaker. I work for Keyrock, and we are a market maker and in digital asset markets, and we trade hundreds of markets and thousands of instruments. We manage millions of orders a day with an automated trading system that's built in Rust. Rust has been an absolute integral part of our tech stack and a key reason in our success. And I just wanted to kind of give some background because we're going to talk about how we use Rust and Rhai, a scripting language that provides a lot of flexibility for us. But to get into that, I wanted to go into some of the context that we're using it in and start with what is the price of an asset. When you go to the store, obviously there's a single price for the item that you want to buy, and you can buy as many of them as they have there. But when you trade markets like stock markets, futures markets, forex markets, it's a continuous auction model where anyone at any time can say that they're willing to buy or sell some quantity of the asset at some price. So the best price, there's a limited amount at that price, and as you want to buy or sell more, you have to pay or accept a lower price as you go up. And so what this chart represents, and by the way, this chart was generated with a Rhai script. This chart shows the price that you would have to pay to buy or sell more and more of the asset. And the top line, the darkest red line is to buy $5 million worth of the asset, and the darkest green line would be to sell $5 million of the asset. And as a market maker, when we are trading many, many different markets, we're interested in what is a good price to buy or sell something at. And there's a lot of different considerations that go into that. Liquidity is the word that we use to refer to how much of an asset you can buy or sell quickly. You could maybe theoretically sell a lot of it over a year or so, but how much can I buy or sell in a second or a minute? And exposure is how much of something we already have. We're not interested in trade. We're not buying something so that we think the price is going to go up. We're trying to stay market neutral. We don't want to. We're trying to avoid the risk of holding on to something all the time. And so if we have a lot of it, we don't want to buy a lot more because we're at risk that the price could go down while we're holding it. Latency is a huge part of what we do because the market trades very quickly, and we need to be monitoring. How stale is our view of the world? How long ago did we get our data, and how long did it take to get to where we are? Whatever data center we're operating in. And how long does it take us to cancel an order if we want to get out of where we've posted some price, but we realize that's a bad price? How long will it take to get out of that? Volatility is how fast an asset price goes up and down, and that changes. It's something with trends. It ebbs and flows. And then there's just execution risk, like software bugs. I think you guys have probably experienced that, but when you're trading millions of dollars of something at a very high clip, that can be a very big problem. We also have like SLAs, like we have clients, we have expectations that we'll be posting a price in a market for some percent of the time. So there's a lot of constraints, there's a lot of things that go into our calculations about pricing. And it's something also that needs to be something we can customize, iterate on, move quickly to change in the face of different changing conditions. One of the biggest differences between some set of given markets that we trade is liquidity. And if you look at these different currency pairs, there's tremendous difference in how much trading volume there is. So you got Euro USD, $1.8 trillion in trading volume every day. Bitcoin dollar at 30 billion, and Monero dollar 100 million, and Doggy 20K. They're completely different things. They're not at all the same, and they don't exhibit any of the same characteristics. So we have an automated trading system that is doing all these trades on our behalf without direct human intervention. But a very important part of how that system works is that we're customizing the parameters of it to the individual markets that are really different from each other. And that's a core reason why it's important for us to be able to have this hatch, this scripting hatch, so that we can customize things. And just real quick on Rust. So back in 2017, before I worked for Keyrock, is when I got into Rust. And the first reason that I got into Rust was that I was trying to study market data with Python, and I had worked really hard for like a couple weeks actually to get the update for each new market, piece of market data faster than 500 microseconds, which maybe doesn't seem like a long time in some sense, but when you're dealing with like huge amounts of market data, that can be a lot. So, if you've got 75 updates a second, and each one of them takes 500 microseconds to process, if you want to go through a week of historical data, that's going to end up taking you 6.3 hours. And that's a long time to get an answer of what your analysis will say. So I was struggling with this, and I knew a little bit about Rust, started experimenting with Rust, and my very first Rust program, I was able to get that 6.3 hours down to 33 seconds, and then, I never looked back. I like to say I came to Rust for the speed, and I stayed for the safety, because the thing that I ended up learning is that, if you write idiomatic Rust and you handle all the errors, your program's going to be pretty solid. It's going to be pretty bomber. And so meanwhile, while I was doing that on my own track, Keyrock had kind of a very similar path, where Keyrock was a company that started off developing in JavaScript, and they wrote a lot of code in JavaScript, and they were using it to trade, and they had a few different problems from that. One was, one of the things we do, we trade different markets for the same underlying asset, and then we kind of bring together the continuous auction order book from those different markets into a global view of all the orders that are out there at these different places. And doing that in JavaScript was just too slow. Then the other thing is garbage collection pauses. So you're allocating over and over and over again in Node.js or whatever JavaScript runtime you're using, and we would get GC pauses of about 100 milliseconds every 1 minute. And that is just not something you can have in high-frequency trading. And then the third problem was the type unsafety and runtime errors. It was a constant problem where you would run into things that there's some unexpected condition, and boom, you raise an exception, you didn't catch it, and your program crashes. So Keyrock had the same kind of path. They looked at Rust. There was a big internal discussion about it, and one of the senior developers said, all right, unless this is extremely fast, I think it's too much work, too big of a learning curve. He did a little prototype, and oh my gosh, wow, that's fast. Sometimes when you come to Rust for the first time, it feels like a superpower, is how I put it, right after I'd learned it. So, that's how we got to Rust. We're going to go through a quick example of what it is about Rhai that's exciting as a Rust developer. So we're here at a Rust conference, but we're talking about a scripting language, which is kind of interesting. The reason why it's interesting to Rust developers is because of its seamless integration with Rust. It is really easy to create a interface to your native Rust code to be able to interact with from a scripting language, and it's really nice to use, and it allows you to have a kind of way to interact in a scripting way with your native Rust types. So on the screen, we have some code, and it's you've got a couple structs at the top that represent how you might store an order book. And the particular structs are not super important, but the point is that you have some struct, custom struct in Rust that has an API in Rust that you can interact with it in Rust code. And it's not just a plain primitive type. You've got some, built-in functionality or some things where you're doing something complex. And if you wanted to interact with that in a normal scripting language, you'd have to kind of move it over or port it into the types native to that language. But in Rhai, you can implement a trait, custom type, and simply by having done so, that type is now able to be used in a Rhai script. And it's very, very, very simple to do. It doesn't take very much time. It's not a lot of overhead in terms of coding to get to there. And then at the bottom, you'll see like an example Rhai script. And if you have an instance of a native Rust type, like an order book that we just saw, you can place it into the scope of the script in different ways. But assuming that orders, the variable binding at the top of that script, is in the scope of your script, you now have the ability to call all the methods that we defined in that custom type trait implementation, and you are acting on the native Rust instance. And the back and forth, the wall between these two things is pretty seamless. So there's a flexible ergonomic API to define a Rhai API for your Rust type. You can easily put instances of the native Rust types in the Rhai scope for the script to read and modify. And you can return a native Rust type back to the Rust side of your code very easily. And then I think, so obviously scripting, embedded scripting has been used for a long time, and Lua is the most popular scripting language that you would use. It's got a rich history of being used in gaming engines, for instance, which is kind of a similar situation to trading. But one thing you'll run into if you try to do Lua, for instance, with Rust, is there's this semantic mismatch between Rust and the C-based scripting engine that you want to use. So, for instance, there's going to be an unsafe FFI layer, and there's no the same ownership and thread synchronization. Like rules of Rust will not be applied in the C side of the code, and then therefore there's this it kind of creates pitfalls. It creates dangers of unsafety that you have to deal with, or you have to worry about, especially as it relates to thread synchronization. That's not true in Rhai, because Rhai is implemented in Rust, kind of built for interacting with Rust. It makes it very nice. Just give you like a quick, I think anytime you're talking about a new language that maybe you're not familiar with, you might want to look at what it looks like to code in that language. I think that's obviously what I want to see when I'm looking at any kind of new language. This is a quick code example taken from the Rhai GitHub that just shows what a function looks like. A few, the if. It's very similar syntax to Rust. It's very easy to pick up if you know Rust. The main difference is dynamic typing. So if you've got a variable binding x, you can put a floating point, a string in it, integer, an array, a map, anything like that. That's just kind of the nature of it. That's how it's different. Functions are kind of interesting in Rhai, and you've got a few different things that are notable about it. One of which is there's closures that are pretty limited. Like they can close over variables, but they can't really modify them, or it's very hard to modify them. So you can't do the kind of thing in Lua where you would enclose over some local state to the function and modify it. But there's also a this keyword works similar to how JavaScript and this works. And there's method dot notation on objects that you can call, and it will refer to the this. And there's function pointers. You can pass a Rhai function back to Rust if you want. Also, when you're defining that custom type interface that lets you interact on a Rust native type, you can use function overloading and call the same name of a method on several possible signatures. Now, Rhai has exceptions and try and catch. So personally, I'm the kind of Rust developer where the feller crate. I don't know if you're familiar with it. It's got a throws proc macro, annotation macro, where it kind of gives you a try-catch exception semantics. And that to me is like, no, I love the result type in Rust, and I love handling errors up front as values. And that to me is like a very important part of why Rust code produces programs that are as solid as they are. However, that being said, from where I'm coming from, I really do like exceptions in the scripting environment. If you do throw an exception, if your script fails, you're going to catch the result on the other side in the Rust code where you're executing the script. So it's not like it's going to crash your program. And it's, the whole purpose of providing the scripting interface is to be convenient, easy, customizable, provide fast feedback cycles. So it's a very nice way to kind of provide a little bit of a context where you don't need to write like super solid, cover all your bases code like you would in Rust. A few limitations worth mentioning about Rhai as a language: no classes, no traits, no structs, although you can define that custom type interface, so you have the ability to interact with Rust structs. No tuples, keyword arguments, no async. There's no paradigm for having concurrent blocking code in Rhai. Limited first-class functions. There is some first-class functions, but it's not a fully fleshed out paradigm in Rhai. And one big one is if you pass a Rust type into the Rhai scripting context, you need an unmute unique reference. So you can't pass a shared reference to the Rhai scripting environment. That's not part of the design, and it does change how you design your programs a little bit. Performance is about what you might expect from a dynamic scripting language. It's about the same as Python. It's slower than like JavaScript V8 or LuaJIT. So the best way to use Rhai is a thin layer over Rust code where you're kind of dispatching work to be done in Rust. It's not the place where you do a ton of work in the scripting language. There's some, I think, having looked at the source code of Rhai and look, the authors pay a lot of attention to performance. My expectation is that over time, performance will get better. Right now, it's not super fast, and it's not the place where you want to do a lot of work. The difference between using Rust plus Rhai and like Python, though, is most of your program is going to be in Rust, you're just going to use Rhai as this little, to control some little part of your program, not the whole thing. And like I said, it's best used as a thin layer over Rust. You also get really fine-grained control from both a performance perspective and a security perspective in Rhai. There's a lot of knobs that you can tune. Some of those make Rhai run faster. Some of those limit the resources that a script can use. So you could even let users define their scripts without that being a big concern. And that means users in a broad sense. In our case, we're having internal users that are not full-time developers write these scripts, and because we have the ability to control these parameters, it allows us to give them more leeway than we otherwise might. It's got active development. I've submitted some pull requests to Rhai and just kind of or issues to Rhai, the GitHub, and kind of been amazed at how responsive they were. There's a lot of resources. The documentation is excellent. They've got a playground. They've got a language server. They've got a way to generate documentation, kind of like RustDoc works. It's a very full-fledged project and very impressive in what they've done. So we're going to talk now about a key application of how we use Rhai at Keyrock, and that is for custom pricing indicators. Indicators, if you know anything about trading or you've kind of maybe heard a little bit about trading, you might think of indicators as some kind of moving average or a statistical aggregation of prices that gives you some, maybe smooths some data or gives you some signal about what's going to happen. And that's a very good way to think of it. But internally at Keyrock, it's also just more of a broad term that can refer to any kind of numeric representation of the state of the market. That includes our exposure, how much we own of some asset that we don't want to own too much of, or want to kind of control, and things like that. And it's also not. A lot of times you think of quants and genius, creative people who've developed some means, stochastic calculus to produce the statistical equivalent of a crystal ball about what's going to happen with prices in the next 5 minutes or hour or whatever. And in our everyday usage, it's not really that. It's more just disciplined application of expertise and watching changing conditions and applying those and things like that. So we wanted to provide a way to build these indicators with a few different goals. Like, we wanted to be able to make them flexible and customizable in an arbitrary way. And also with that, have hot reloading, where you can change them at runtime without restarting your system. Because if you have a high performance system that is in use, it's doing a lot of different things, and it can be very costly to bring it down during normal operation. So the ability to change things about how it works without bringing the entire system down, without deploying a new build of your entire thing, is really valuable. And that's like a key thing of what we wanted to do with it. And we also wanted to be able to empower people who aren't full-time Rust developers to be able to modify this system and use this scripting kind of escape hatch, if you will. And Rust development is, you guys know what that's like, and you might not be able to expect. We have a team of traders who are really smart people, but they're not full-time developers, and we want them to be able to be empowered on their own to make changes to this. So Rust, defining that Rust code that might do the same thing is not really viable in that context. We also have constraints. One of the biggest is performance. Speed kills in high-frequency trading. If you have a bottleneck or you have something that makes your system lag, you will lose money very predictably. And it can't be allowed to happen, and it does happen, but when it does, it's a problem. So this has to work really fast. Fortunately, Rust is an easy way to build fast programs, and most of our system is in Rust. And we've got kind of a little tiny section that is the Rhai section where these numeric transformations are applied, and the performance has been decent. It's been fine. It's not been a huge issue for us. The other thing is traceability, auditability. So when you add this layer of embedded scripting, it's a new layer of state that exists at runtime, and you need to be able to know what the state of what it was that was in place when something happened, not just at right now, but also at some arbitrary point in the past. And so that was kind of a key thing that we were trying to get done with this. So custom indicators is our internal term of art that refers to a Rhai script that is executed to build one of these numeric indicators. And the inputs are other indicators, some usually generated by raw Rust, native Rust code that is ingesting market data, or we have some kind of data in the system that then the Rhai scripts act on. And in concrete terms, there's a initialization script that runs to create some scope that some state for the script to be able to modify and keep track of things. And then there's also like an update script that is run every time a new piece of data gets in. So here's an example of what it looks like in Rhai code. And you see at the top, you've got the initialization script, and it sets up this variable scope, which is by convention what we call the state that you're going to be able to use later. And then the update script And you see that like variable delta exposure EUR 330. And so in Rhai, you can, like I said before, you can put a native Rust type, instance of a type, into the scope in different ways. One of the ways is like manually adding it to a variable, to a type called scope that is part of the execution environment of the script. Another way is something called a variable resolver, where you tell Rhai, when you get to a variable that you don't know what it is, come to this object which implements some trait, and it will tell you how to get that value. So those names, delta exposure EUR 330, that refers to another indicator, and it's like, there's obviously conventions that we use in naming these things, and so you can, any of the indicators that exist in the system can be used to compose another indicator that's the result of the execution of this script, and it's updated whenever new data comes in that it subscribes to. And we have a service that handles this called indicators composition. It listens to the data. When new data comes in, it updates the indicators that are based on it, and then it publishes the new data to subscribers of that indicator. And we use it very heavily in production. It's a very key part of our stack and drives our pricing calculations in a lot of markets that we trade. And we have thousands of them running at any given moment. Some of the challenges that we have faced have included performance, just making sure that it's running as quickly as possible, and part of that is using some of those knobs to limit what is available in the scripting environment and how many resources the script can use. That also leads to another challenge, which is balancing giving enough power to our users to do what they want without making it run slower than we want. And then, tracing, debugging, being able to understand and debug and track the state of what the script was at some point in time. And you obviously open up the possibility of human error if you're letting human analysts write scripts that are executed throughout the trading day. And one of the kind of biggest ones is NaN propagation. Anytime you're dealing with floating point numbers, if you have a NaN, it can end up kind of spreading throughout all the other numbers that are based on the calculation, and that can happen sometimes. Handling errors is a little bit of a tricky issue because in Rust code, if you come across an error, you've got a lot of options of what to do with it in terms of your fully fleshed out complex system. You've got logging, metrics, whatever. But in the script, what do you do when you get to that? I mean, you can just throw an exception, but sometimes it's a little bit more difficult to deal with that problem in the script. Another one I would mention is that it's still a new language. It's a little bit unknown and it's arcane. And so when if we hire a new trader and they come to work for Keyrock, they won't have heard of Rhai. They might have used Python before or JavaScript, but they won't have usually used Rhai. So it's a little bit of a learning curve there. So that's a little bit like that's a little bit about a system that we use in production at Keyrock. And the next thing I'm going to show you is a little bit more of a prototype experimental project that I worked on that is meant to kind of give you some more imagination about what you might use this for. And the scenario here is that you have a production system, high performance production system with a lot of data inside of it, and that you want to access that data. So if you have some high-performance system that is really dealing with a large volume of data, it's not always that easy maybe to write it all out somewhere else that you might access it. Like writing to a database or some other data store might be expensive for different reasons, or it might just take time and effort to do that, and it might not be there already. So you have this need that you need to access the data. You want to be able to inspect the state of the system at runtime, access the data in some way. And let's say this system already has like a lot of functionality about how to analyze or look at that data. A lot of times you have a big Rust program with a lot of stuff that you would love to be able to use, except for it's hard to use it on the data that you have at runtime because you'd have to write a whole bunch of Rust code to be able to do that. And it's like maybe the function exists, but the way to use it at runtime doesn't exist yet. And you want to be able to do ad hoc analysis with it, but you don't want to have to reinvent the whole wheel over and over again to be able to do that. And the core idea here is you want to provide a means to interact directly with the data inside the program without any layer in between for different reasons. And this has happened to me before in systems I've worked on several different times. So we've got Rhai, and extending a Rhai interface to native Rust code is easy and fast. Like, it doesn't take a long time to build this interface so that you can interact with the Rust types. And you get hot reloading. You can modify this script at runtime without restarting the system. That's like, number one important aspect about it. And it's flexible because you can run scripts, like fully fledged scripts, if you've got a really specific purpose. You can create a REPL, and kind of interact directly. You can even or do query language like stuff, which is what we're going to show. And you can allow users, one mode of Rhai that you can do is a single expression, for instance. So you're not doing a whole script, you're just doing one expression. Just for example sake, this is a couple Rust types of a database and a time series that is stored by the database. And those would be the types that you would be interacting with, and you would extend a Rhai interface to them. So for time series, for instance, you might have a resample method on it that lets you downsample the data to some other frequency. And this right here is a screenshot of a custom Grafana plugin where the input is not a query, it's a Rhai script. And the Rhai script is then sent to your Rust program, and it executes the Rhai script on the internal data of the Rust program and returns data to Grafana in the form of arrow IPC format and allows you to visualize what's happening in your program. And there's a couple of things that are kind of interesting about how this works in this case. This is a close-up, a little bit closer of the script itself. And unlike most query languages, which are declarative, this is imperative, and you can store variables and you can loop over things, which is pretty powerful. And you'll see a variable binding DB, and that would be a Rust native type that you've put into the scope of the script. So in this case, what I did here is there's a convention that there's going to be this global DB object that you can use to fetch data from the system. And you fetch it by name, you pass a string and you get that data back. And then you've also got some variables start and end that are timestamps representing what the range of the Grafana view is. So if you zoom out, you can limit, filter what you're looking at. And then the series name is the name of the measurement, the metric, the thing that you want to pull out of the DB. And then we use that to fetch data from the DB. We also return like a map, like a dictionary type object, where the key is a string, the series name, and the value is a time series instance, which is the native time series instance that we're passing back from Rhai. And then the other example I would show here is, you remember we talked about using this as a thin layer over Rust. So for time series data, it's usually high volume data with you can call a native Rhai function on 10 million things, and it might take a while. One method you can use that works really fast is to call the name, pass a string to Rust, match on that string, pick out several kind of predefined Rust functions that are in native Rust, and then do the work in Rust where you map over those 10 million things using the native Rust code. And that's going to be a lot faster than calling a scripting function 10 million times. So, just in conclusion, Rhai's superpower is its tight Rust integration. So the thing that makes it useful to Rust developers is that you can easily go between the two worlds of your native Rust code and your Rhai script. And that is really, really valuable. And even though Rhai is not as fast as LuaJIT, and maybe the language isn't, it's a great language, but it's, there's some things about it maybe I would change, but not all scripting languages have this really seamless, tight interoperability with Rust, which makes it nice to use. And other thing is, for best results, keep it as a thin layer over Rust. Use Rhai as a way to dispatch work to Rust, for Rust to do, and that's like a really great way to use this scripting language. So that's my presentation about Rhai and Rust. It's something we use in Keyrock every day, and I've found it to be a really valuable tool. I think it's a really promising tool that's got some room to grow as something that Rust developers use. And with that, I'd be happy to answer any questions.
Yes, any questions, please raise your hand.
Hi, so my question was, as Rust matures more as a language and becomes more mainstream, there's going to be more effort into making more mainstream scripting languages like Python or Lua interop with Rust. So I guess as that comes around, what do you think is going to set Rhai apart, continue to set Rhai apart from things like Python and Lua and keep people using them even as there's more support for those other scripting languages?
Yeah, that's a great question. I've used Lua as an embedded scripting language in Rust as well. LuaJIT is amazingly performant for a scripting language, and it's an incredible project in its own right. I think even using a safe Rust layer, FFI bridge between Rust and Lua, you do still run into this semantic mismatch quite a bit. So you end up needing to do a lot of conversion between Rust code and the native types of the scripting language like Lua or Python. And that's very expensive to do. And it also takes a lot of development work. It's not easy to get your Rust data into a type that can be used in the Lua environment always. So that's what sets it apart a little bit, is that first of all, you don't have this semantic mismatch in between the borrowship and thread synchronization of Rust versus your C-based scripting engine. And then the second thing is just the ease of passing native Rust types back and forth between the two environments.
Hi. Hi. I just, first of all, thanks a lot. That was really interesting. You mentioned at some point that there was no JIT for Rhai. So sort of a two-sided question. Do you see an upside to it being worked on? And do you see anything in the way of that, generally speaking?
So Rhai does not have a just-in-time compiler, like you mentioned, and I think from what I know, it's not something on the roadmap of that the Rhai project is interested in developing. I'm not a Rhai developer. I'm someone who uses Rhai in application programming elsewhere, but there's no reason why you might not do it. That would prevent it from being done. Obviously, just-in-time compilation is a very complicated beast to pull off, but it could be done. My expectation, having followed the Rhai project pretty closely, I'm expecting performance to get better over time, and I just think that for a variety of reasons. Just watching how carefully they're tracking performance, the benchmarks, and things like that, I think that will get better. Rust enables you to build fast programs, and I think it will get better over time. Whether that includes a JIT or not, I don't know, but there's no reason it couldn't.
Thank you.
Thank you for the presentation, and I want to add a couple of words about Lua. I'm a maintainer of Lua project. It's a Rust integration with Lua. It supports multiple Lua engine, including the Lua JIT, and the recent one is the Roblox Lua U, which adds a lot of safety. Also, it provides unboxing out of the box. Also, Lua provides a scene integration. It's fast, and it brings lots of safety to the Rust. Yes, it's built on top of the FFI. It's true, but it exposes, I hope, the same level of safety as Rhai. Yeah.
And what's the name of the crate that you use?
Is MLua.
MLua?
Yes, it's used in production.
I've used MLua. Yeah, MLua is great. As far, for a Lua interface, like I've really enjoyed using it.
Yeah, it also provides seamless integration with Rust types, so you can expose any Rust type to Lua, call it the same way as Rhai. So I work hard to make it better over the past year, so it's rapidly developing.
Thank you.
That's it.
Hi. Thank you for the great talk. It was very interesting to see Rhai in the real world, so to say. My question is maybe a very generic one, but throughout your talk it seemed that despite the Rhai having a lot of neat features such as dynamic typing and basically providing you as much flexibility as possible, the two use cases you have displayed there are maybe not using that much of a Rhai itself. Like for the indicator computation, it seems that you mostly need some basic formulas and some maybe flow control like if statements. Maybe some indicators are more complex than you have displayed. Maybe they need some functions. And for the time series part, you said that you basically offload the vast majority of the processing to Rust. So basically, the Rhai is used, as you have said, as more like a dispatcher than anything else. My question is, did you consider writing your own very small language just specifically for this task? And this might sound a little bit insane when you first hear it, because, well, writing the whole language is hard. But once again, it seems to me that you do not use that much of the language itself. So writing like a very, very simple dispatcher more than anything else might be an option. So yeah, the question is, did you consider it? Or?
Yeah, no, I appreciate the question, and personally, I have a higher tolerance for things that might sound insane than most people when it comes to development, because sometimes that's the best route for high performance systems, things that are really customized to what your specific context is. It's not something that we considered at Keyrock for the use of custom indicators. It's certainly possible to do that. I think that the thing that would worry me about it is the work that it would take to get there, and then also that like for instance, that wouldn't come with a language server, that wouldn't come with an online playground, that wouldn't come with all the tooling that you get. But it could be done, and I'm sure it might end up being faster that way if you did, customized to your specific thing. But that would be why you might not do it.
Makes sense. Thank you.
Hello, and thanks again for the talk. 2 questions. You haven't shown how the scope binding actually works between Rust and Rhai, which I think is a very interesting part. Particularly, can you limit what Rhai sees, and can you limit also the ability to mutate it in such a way that you can expose data to it without risking compromising the state of the underlying Rust program? And the second part is, have you implemented auto-reloading? Like, how much heavy lifting have you done compared to what Rhai provides out of the box?
Can you, the second question, I didn't quite hear you. Can you say it again?
There's a bit of a... And say, how did you implement auto-reloading? Like, how much of it comes with Rhai out of the box? How much do you have to build to make that work?
Right, got it. Okay, so yeah, I didn't show that for time reasons, but essentially there's a type called scope in Rhai that it's just a list actually. It's not it's not a hash map, where you append items to the list of variables that are in the scope. So you explicitly specify what scope the script has access to, and then that script, is there any ability to prevent modification? Not that I'm aware of per se. I think you could control it in terms of what interface you provide to the type. So you might wrap it in a zero type struct that has no methods on it, so the Rhai script can't do anything with it, or except for read it through a specific interface. Is maybe how you would do that. In terms of what functionality exists in Rhai out of the box, there's general math, arithmetic, operation, add, subtract, divide for numbers. There's for arrays you get map, filter, like a good deal of the iterator interface on iterable arrays in Rhai, but there's not a ton. There are a few projects to extend that beyond just what's built in, and that includes like a scientific, providing some numeric operations on lists of floating points, or arrays of floating points, and you also get fine-grained control over which of those packages that are enabled in any given scripting engine instance. So you can really dramatically limit it to just one or all of them, or new ones, new packages that are added, and there's quite a lot of flexibility with that as well.
So you mentioned about being able to really limit the amount of resources that were taken up by an individual Rhai script. Is that something that is part of the Rhai runtime, or is that, well,
Yeah.
it's called Rhai runtime. There isn't really a Rhai runtime, is there? It just runs native Rust.
Yeah, I was just going to go back to, I have a list of the things that you can, so see that bullet point, robust sandboxing limits. The things that you can limit include length of strings, arrays, maps, number of operations, number of modules that are added by the script, the max call stack depth, max expression depth. I think there's others beyond that, but it generally includes pretty much all the things that you would want to limit, either through the at runtime in how you define the instance of a type called engine, or through conditional compilation feature flags in the Rhai crate.
And when you're trying to track down performance issues with, you've got a desk full of traders, one of them's caning all the CPU resources, is there a lot of tooling in the Rhai toolbox to really profile what the scripts are doing, who's using all the resources?
There's not anything profiling in the way of profiling beyond how you would profile a normal Rust program, to my knowledge, but I might not know about it. There is the ability to limit how long a script takes. It won't just go on forever. You can prevent it from doing that with knobs that are included in Rhai.
Okay. And are there a fair few VS Code plugins for writing Rhai and all that?
Yeah, Rhai does have a VS Code plugin and some other ones. I haven't used I use Vim myself, so I haven't used it, but that exists, yeah.
Okay,
cool. So you mentioned auditability being one of your requirements. What about these scripts? Can you audit, and is there anything in them that actually needs auditing or tracing?
Yeah, in that sense, one of the things we closely track all the modifications that occurred, so that you have a history of, if you modify a script, then you know what it was then, and then you know what it was after the modification, and who made the modification and when. And that's I don't think we don't have tooling that we've built internally to inspect the internal state of the script while it's running or something like that. But if there's anything else you're imagining or thinking about, maybe I could answer it. But that's all that comes to mind.
Hello, thanks for the talk. How does the ownership of Rhai objects work when you get into Rust? Like if you have when it's passed over, does the Rhai language keep ownership of it and Rust only has a pointer into it, or is there some kind of reference counted wrapper around the objects?
So essentially, when you pass it over, you kind of pass a ownership of the instance. So you're usually passing things that are clonable and cloning it over to the scope of Rhai. In that sense, it's pretty useful to pass over things that are heavyweight objects behind an arc, or something like that. Like for instance, in the case of the time series DB, DB is just an arc reference that you clone over to the scope. It's not really a paradigm that Rhai allows for you to kind of pass it over to the scope and then get it back later and then act on it again. It's more like you give things over to Rhai and then you get something back from Rhai, but you don't share a lot of data in between the two worlds, unless it's with a behind an arc or something like that.
So it wouldn't be possible to pass like a mutable reference to Rust and for it to mutate an object in the Rhai ecosystem?
No, well, it has to be owned by the scope. You can then get it out afterwards, I guess. But the Rhai limitation on calling a method on the Rust type in a Rhai script is it's got to be an mut reference to it itself. And then Rhai will also, it will tend to clone things when you call functions and so on and so forth. So in terms of modifying a Rust type and then like seeing the modifications later in your program because you got the reference back, it's not really a good way to use it. You more would return a type from Rhai, or maybe if you wanted to do that, you'd have to do it with some kind of synchronization, like put it behind a mutex and then use it that way. So you can clone it over there.
Thank you very much.
Yeah.
Hello. I was really excited by your Grafana plugin. I thought that was a really great use of Rust and our IPC. I was wondering if you had any plans for open sourcing something like that.
I hadn't planned to or thought of it yet, but it was just kind of an experiment and a program. The Grafana plugin was kind of an interesting process. There's a Rust crate. It's a little bit bleeding edge to do that. I found it fairly easy to use. It's I think that, the hardest part was converting over to the Arrow IPC format, and I used the Arrow 2 crate, and that ended up being great. But one thing I couldn't get out of it is I couldn't avoid copying all the data in order to serialize to Arrow IPC. There wasn't a way to do that because the Arrow format is kind of it's a C library that you're ultimately calling, and for safety reasons, they didn't allow you to just pass a reference and so on. But yeah, it was pretty easy to do. It didn't take a lot of work. It's a tonic-based gRPC back and forth with Grafana is how it gets accomplished. I'd be happy to post like an example of how that works somewhere, and that could be shared. So just to show how that is.
Yes, please.
We've probably got time for one more question. There we go.
Hey, so as you traders are basically developing these custom indicators, have you basically observed the pattern that they become more and more involved, and then you will want to translate them to like a Rust implementation that's more performant?
Oh yeah,
and
absolutely.
Then traders go back and want to make changes to that, and like there's some back and forth. Like, how do you manage that?
Yeah, well, we definitely have like quite a lot of our indicator subsystem. We have a bunch of Rust-based indicators that are doing high performance calculations on the Rust side, and I don't think we've really had the problem of that we end up taking a custom Rhai indicator, putting it in Rust, and then having the lack of flexibility hurt us. It hasn't happened yet. Maybe it will someday. But it tends to be that last Rhai layer is more like combining several of them in some intelligent way, like, you know, a market's only open some days of the week, so when that's open, use it, but if not, use some fallback. Or, you know, like use the most recent one. If it's more stale than this, make the price more expensive. It's just, it's not really like, we're not doing like, you know, super advanced numeric calculations in Rhai. It's more like a kind of control layer at the end.
Thank you very much. And can we have a quick show of a round of applause to say thank you?